Last time, if you saw that video, we talked about the first layer of nomenclature, which was just elements and some metals, group 1, group 2, and a couple of other ones. Today we're going to get into all the rest of the metals. Now, you may or may not have seen it, but if you didn't, or if you did, either way, one of the things to remember is that the most important thing is that all previous nomenclature stays the same. So what we're learning this time will be different from what we learned last time, and we don't change anything that we did last time. So the metals that we looked at last time in our first week of nomenclature were group 1 metals, group 2 metals, group 13 metals, some of them anyway, and a few others that were scattered around. And the thing about those was that those metals only have one possible charge. Anytime they do make a compound, they only ever do one thing. So you recall we said, say for example, group 2 was always +2 in a compound. Germanium was always +4 in a compound. That means that we know what they're going to do every single time we do it. It also means we have a question. What about the other metals? And the short answer to that is they don't always do the same thing. Sometimes they'll do this, sometimes they'll do that, which means we need to know what they're doing. Which also means that we need to say what they're doing when we're doing nomenclature. So not only do we need to know what the charge on the metal is, we also have to state it when we're doing our nomenclature. So let's start with naming of the compounds. How we're going to indicate the charge is using a Roman numeral. Now, if you're not really sure what the Roman numerals are, we'll list them off for you at some point, probably not right now. We only need the first 7, so maybe 4 and maybe 6 you'll get mixed up once in a while, but other than that, we're not getting into 57 and things like that. So the one possible you'll see for a compound between iron and oxygen is iron 2 oxide. What that Roman numeral 2 means is that iron has a +2 charge. That's all it means. The other possibility, not that we need to know how many there are or what they are, but the other name you'll see is iron 3 oxide. That means iron has a +3 charge, and that's all it means. So if I were to ask you to name this compound, well, I can look at the periodic table and I can identify that Sn is tin, and I see oxygen. Well, I remember from last time that oxygen is always -2 with metals. Sn, tin, is a metal. So I know that oxygen is -2. I also know that there's 2 of them, giving me a total negative charge of -4. I also know that the total positive charge will equal the total negative charge. That has to mean that I have a total positive charge of +4, right? It just makes sense. That means then that the charge on Sn, tin, has to be +4. Now in some cases that +4 will be a total that's divided up between multiple atoms, but in this case I only ever see one atom of tin doing that, so it means it is the entirety of the +4. So Roman numeral for 4, IV, so my name becomes tin 4 oxide. Looks like a lot going on, but hopefully you'll see that it is a certain amount of logic, a certain amount of, well, that just makes sense. Let's try another one. If I gave you this compound, Cu3n. So you can look at the periodic table. Cu is copper, definitely metal. N is nitrogen, so we know what to do with it. We also know that with metals, nitrogen is always -3, and the little 3 by the copper atom there means that there are 3 atoms of copper. Those things are going to become important. So, as I said, N is always -3, so the total negative charge there is -3. That means the total positive charge has to be +3. But that +3 is carried by or delivered by a total of 3 atoms of copper. So each one must have a +1. +1 times 3. That means then that the Roman numeral that I'm going to use is the 1. Copper 1 nitride. Now you'll notice that there are 3 atoms of copper and I've got the Roman numeral 1, and that's because the Roman numeral tells me charge. It doesn't tell me a count of anything, it tells me charge. Writing formulas, well, that's actually much easier, because if the total positive charge equals the total negative charge, then all I have to do is make sure that the numbers balance out. So crossover and reduce will work. The one slight difference from last time is that last time I looked to the periodic table for the nonmetal and I looked to the periodic table for the metal, find out what the charges were. But if I look at the periodic table for the metal now, we didn't write anything down. But don't forget, it's in the name. So if I write chromium Roman numeral 6, and no, you don't have to say Roman numeral all the time, it's just chromium 6 sulfide, I know that chromium is plus 6. That's what the name says. Roman numeral 6 means plus 6. I also know that sulfide, because it's in group 16 as a nonmetal, it has a charge of -2. Do the whole crossover reduce thing, you get CrS3, chromium 6 oxide. You'll notice no 6 in the name, in the formula, because the 6 is not counting anything. The 6 is telling me the charge on the chromium. One last thing, and I cannot stress this enough, and this is probably where people get hung up and trip over this the most, is the Roman numeral only tells me charge. Roman numeral's not counting anything, it's just telling me the charge. And I never write the charge on the formula, so where I'm looking for that to show up, it's not going to. It's just telling me the charge. After that, it's just on to the next layer. Hope it helps.